Everyone. This is Algebra 1. This is Unit 6. We're talking about polynomials, and today we're going to talk about adding and subtracting polynomials, and then some of the terminology around polynomials. So our goal today is to identify the degree and the number of terms of a polynomial, and to be able to add and subtract polynomials. And adding and subtracting polynomials, we've actually done that before. This is something that you should know how to do. We're just going to be using some different vocabulary when we talk about it. So rather than saying, adding and subtracting equations or expressions, we're going to be talking about specific polynomials. And then moving forward, we're going to be studying some of the different types of polynomials, right? And those are generally kind of regarded by their degree. And so the degree of a polynomial determines the shape of the graph. It determines kind of the behavior of the polynomial and some of the unique features of that polynomial. So we're going to kind of divide those up by their degree. So determining the degree of a polynomial is going to allow us to kind of categorize those polynomials that we study moving forward. Okay, so the first thing we want to talk about is what's called a monomial, right? A monomial is a polynomial, okay? A monomial is just simply a product of some number, right, which we call the coefficient, and a variable. Okay? And it could be multiple variables, but it's just the product of those, all right? So we talk about a product of those. We can also talk about, a product or a quotient. So product and quotient are considered, the same kind of operation. It's multiplying by an inverse, but so we can classify those as something that's a monomial, something that's not a monomial. And so the other way we talk about these, we talk about a monomial as a term. Okay, so we've talked about in the past, we've talked about terms of an equation and how when we simplify, we want to combine our like terms. That's where that comes from. We're talking about terms here, and the terms, another word for that is a monomial. All right. So if we look at these, look at these expressions on the center here, we can try to classify these as monomials or non-monomials. So let's start with x squared. X squared is a product, right, of x and x. So that is a monomial. 4 times x times y, the product, right, of 4 and x and y, also a monomial. The number 4, okay, just the number 4, also considered a monomial. 3x, the product of 3 and x, monomial. The product of 2 and then x and x and y and y and y, right? 2x squared times 3y cubed, also a monomial. And then 2 times x to the negative third power, all right? So that negative exponent there. So that's also considered a monomial. 1 divided by y, also considered a monomial. And in fact, the only one here that's not a monomial is x plus 2. And it's because it's not the product, it's the sum. Okay, so it's the sum of a variable and a number. That is not a monomial. A polynomial, right, just simply means more than one, right? One or more monomials added together. So a polynomial, if we took any monomials and added them together, we would call that a polynomial. Okay, poly just simply means multiple. And then a nomial is like a term, so they're talking about multiple terms. A monomial is also considered a polynomial. That's kind of weird. Like one term is also considered multiple terms, but just for simplicity, right? They kind of group those together. So a monomial is a type of polynomial. So we can talk about a polynomial by the number of terms that it has. Okay, we can talk about a polynomial by the number of terms that it has. So if a polynomial has one term, we call that a monomial. If it has two terms, we call it a binomial, right? Mono meaning one, bi or bino meaning two. So this is two terms. Tri means three, so that's three terms. And when we get past three terms, we just kind of lump them together. We say, oh, that's just a polynomial. And we might say that's a polynomial with four terms, or a polynomial with five terms, or a polynomial with 12 terms. But in general, we just, after three, we don't use any special language. We just call that a polynomial. All right. Okay, so this is four or more, right? And I think technically there are names for those with four or more. It's just that they get kind of ridiculous and they're not really used a lot. And so we just call them a polynomial. So we have the number of terms. So we can talk about a polynomial by its number of terms. And then we can also talk about a polynomial by its degree. And when we talk about a degree, the degree of a polynomial is the largest exponent on one of its variables. Okay, so for a single variable, right, if it was x squared, for example, that would be a degree of 2. If it was an x to the fourth, that would be a degree of 4. Okay. If it has multiple variables, right, if it has multiple variables that are multiplied together, then we add up the exponents of those variables, right? So for example, in this one right here, we have 2x to the second, y to the third. Well, we have two variables multiplied together, and we have multiples of those variables. So there's actually 5 variables being multiplied together. So this would be a fifth degree polynomial, a fifth degree, a fifth degree term. Okay, so we talk about the degree, and then we have some specific names that we call so if it's a constant, right, which means the degree is 0, which means it does not have a variable with it, right? A constant, we call that a constant. Okay, so degree 0, no variable, is a constant. A degree of 1. Okay, and when we have a degree of 1, we usually don't write that. So 3x here would be 3x to the first power, right? X is multiplied with 3, right, just one time. So this would be a degree 1. They call that a linear. And the reason is, if I were to make a graph out of all the points that satisfy this, right, it would make a straight line. Quadratic. Okay, and this is the one that confuses a lot of people because it has this prefix quad, which a lot of people, interpret to be 4, right, which is correct. But what this really comes from, it's actually degree 2. So this is degree 2. And where this comes from comes from finding the area of a quadrilateral. All right, so if I had a square, and each side was length x, to find the area of that quadrilateral, right, the area of that square, I would multiply x times x, I would get x squared. So that quad really comes from the area of a quadrilateral. All right, so it's x squared. So degree 2. Degree 3 is called cubic. Okay, and it's cubic because if we were to find the volume, right, the volume of a cube, we would multiply the length times the width times the height. And so if all of those were x, it would be x times x times x, x cubed. So it's the volume of a cube. So it's the area of a square, area of a quadrilateral, and the area of a cube. And then when we talk about quartic, quart also means 4. There's 4 quarters in a dollar, 4 quarts in a gallon. String quartet, right, has 4 instruments in it. So quart means 4. So quartic is fourth degree. So this would be a fourth degree polynomial. Okay. And these are all monomials. So this would be a constant monomial. This would be a linear monomial, a quadratic monomial, a cubic monomial, a quartic monomial, and then a quintic, right, is degree 5. So degree 5. All right. Now, so there's a couple of them here. This one, right, x to the 5th. And then we also have x squared. So this is not a monomial. This is a binomial. There are two terms here. And because we're not multiplying these together, we look at the degree of the largest exponent, right? The largest exponent. So this is going to be x to the 5th. Okay, so this is a quintic polynomial, and this is actually a quintic binomial. Quintic binomial. Okay, it has a quadratic term, it has a quintic term. Okay, it's a binomial. Now we have these examples left over here. We talked about this one already. So I have 2x squared y to the 3rd. So if I add up all the exponents here, I get 2 plus 3 would be 5. And we're multiplying these variables together, so we're going to add up those exponents to determine the degree. So this one is also going to be a quintic. Okay, this is a quintic monomial. And then this one, the degree of the 4 is 0, the degree of the x is 1, and the degree of the y is 1. If we add all those together, we get a degree of 2. So this is a quadratic. Okay, it's two variables, but it's considered a quadratic or degree 2. Okay, so when we talk about polynomials, right, we're going to talk about their number of terms, and we're going to talk about their degree. And typically we say the degree part first, right? And then we say the number of terms after that. So for example, here, this would be a quintic binomial, right? A quintic monomial, a linear monomial. And then the last thing we'll talk about is what's called standard form. And standard form just simply means that when you write out all the terms, you put them in order from largest degree to smallest degree. Okay, so largest degree to smallest degree. So here we have a polynomial with 1, 2, 3, 4, 5 terms. Okay, so polynomial with 5 terms. And if I look at the degrees here, right, if I look at the degrees here, I see this is degree 1, this term is degree 1, that's a linear. This is a degree 2. This is a degree 0, degree 3, right, a cubic. And then we have this another quadratic here, right? So if I put these from highest degree to lowest degree, the highest degree term is going to be 2x cubed. Okay, so 2x cubed is my biggest one. Then the second one, right, are the quadratic terms. So I'm going to put the quadratic terms next. And it doesn't matter which one comes first. I'm going to put this negative 3x squared first, and then I'm going to put xy after that. So plus xy. And then I'm going to write the next lowest term, which would be degree 1, or the linear terms. And there's only one of those. So I'm going to say plus 4x. And then the constant term is always going to go on the end. So negative 5. So there I have that polynomial in standard form. And when I talk about that, or when I put that in standard form, it's very easy to see, right? I just need to look at this first term here, and that tells me that this is a cubic. Okay, it's a cubic polynomial with 5 terms. Cubic polynomial with 5 terms. And then we can also talk about what's called the leading coefficient. So the leading coefficient is when it's in standard form, right? When it's in standard form, the leading coefficient is just the number. Right? It's the number that goes along with that. So in this case, the number here of the leading coefficient. So here's the leading term, right? The largest degree. The coefficient of that is 2. So this would be a cubic polynomial with 5 terms and a leading coefficient of 2. So if we look at some examples here, so they would want us to write this in standard form. So standard form, I'm going to put the largest degree first. So here I've got a constant, I've got a cubic, I've got a quadratic term. Cubic is the biggest one, so I would put that first. Negative 12x cubed. The quadratic is next, positive plus 4x squared. And then there's no linear term, so I'd put the constant term last, plus 2. Okay, and this would be considered a cubic, and there's 3 terms, so this would be a trinomial. Cubic trinomial. If I look at this one, there's only 2 terms in this, so it's pretty easy to put this in order. Then the x to the 4th term is going to be first. Okay, so x to the 4th term is going to be first. This is a negative, so this is going to be negative x to the 4th plus 2. And so we would say that this is a quartic, right? Quartic, because it's 4th degree quartic binomial. Okay, we were asked about the leading coefficient. The leading coefficient here would be negative 12. And for the quartic binomial, the leading coefficient would be negative 1. Right? We don't write the 1, we just put that negative sign there, but that would be negative 1 would be the leading coefficient. Okay, so we talk about adding and subtracting polynomials. The first thing we want to do when we add or subtract polynomials is we want to put them in standard form. All right, so here we're being asked to add 2 polynomials together, right? So if I want to add these together, right? If I want to add these together, and I know I'm adding them together because it's a plus sign here. So if I want to add these together, all I want to do is combine my like terms. Okay, I want to make sure that they're in standard form and when I write out my answer, but mostly I'm just going to put them in standard form and combine my like terms. Okay, so to do this, there's a couple of ways that people will do this. One is called the vertical form. That's kind of like, if we were to add, 312 and 42, right? We would add, we could line them up like this and then add straight down. That's called vertical form, right? Notice when we put something in vertical form that we line up the ones, right? The 1 space, we line up the 10 space, and we line up the 100 space and so forth, right? We wouldn't want to write that right? We wouldn't want to write that as 42, right? Plus that adds confusion to it, right? So we want to make sure that those places, right, those placeholders line up. So this would be 42. Okay. And then I would just add each one of these. Okay. So we're going to do a similar thing with this. When we put these in vertical form, we want to line up the degrees. Okay. So if I were going to add these together, I would take this number right here and I would put it below this number. Right, because they're both quadratic. Okay, they're both degree 2. Okay, and when I do this, I also want to make sure that I have the same variables. So if I had an x squared and a y squared, those wouldn't necessarily be like terms, right? And then I'll take the 7x and line it up underneath here. I'll take the negative 6 and line it up underneath here, and then I'm just going to simply add these together. Okay. And I could go whichever direction I want. Here, we always start on the right-hand side with the 1s, and then we carry. We're not going to do any carrying or anything like this here, but it doesn't matter. We just want to write these down. So if I start here, right, the largest degree, I would have negative 3x squared. Negative 2x plus negative 2x gives me negative 4x squared. 5x plus 7x gives me, what is that, 12x. And then positive 4 minus 6 gives me negative 2. Okay, so I'd add those together. And look, I made a mistake. right? Very common. So I'm gonna make sure and just kind of look those over, make sure that you did everything right. This is supposed to be an x cubed here, right? X cubed. So notice that the degree of this did not change. Okay, the degree of it didn't change. I didn't get rid of any of these, right? That may not always be the case, but but you know, the degree in this case did not change. Neither did the number of terms. So we started with a cubic polynomial with 4 terms. We added a quadratic polynomial with 3 terms, right? And a quadratic trinomial. And our result was a cubic polynomial with 4 terms. The leading coefficient is -3. All right, so that's the vertical form. And then the other thing you'll see is the horizontal form. Okay, horizontal form just means you just write them out horizontally instead of vertically. Instead of lining them up right up top to bottom, we're just going to list them out in order here. So when I do this, again, I want to put these in standard form. I want to put the largest degree first. And then if there's any distribution that I need to do, I want to make sure and do this. Okay, so I'm subtracting here. So this is the same as saying -1 times all this stuff. So this is really plus -x plus +x squared and -4. Okay, so when I write these out, I'm going to write these out. So I'm going to start with my biggest degree, my largest degree here. So this is going to be -12x cubed. Okay, so there's my cubic. I don't have any other cubic terms. All right, then I'm going to look for quadratic terms. And so I've got 4x squared here. And then I've also got an x squared here, but remember that this is not -x squared. It's minus -x squared. So this is going to be +x squared. Okay, so I have that term taken care of. I have that term taken care of. Next, I'm going to look for, I've got quadratic, so the next one would be linear. I've just got one linear term, but again, remember it's not +x, it's -1 times +x. So this is going to be -x. And so I've got cubic, I've got quadratics, I've got linear. The only thing I have left are my constant terms. So I have a 2 here. And this is -4, right? -1 times 4, -4. So I've done my distribution. I've listed everything out in standard form. And now I just simply have to combine my like terms. So I have some like terms here, the x squareds, and I have some like terms here, the constants. And so I have -12x cubed. 4 plus 1 gives me 5 of the x squareds. Subtract -x. And then +2 minus 4 gives me -2. Okay, so I ended up with a cubic polynomial with 4 terms. That leading coefficient again is -12. Okay, here's another one. This is saying vertical form. You know, in general, it doesn't matter, right? I mean, pick whatever way makes the most sense to you. Some people prefer to line things up vertically. Some people prefer to just list them out horizontally. But you do want to show your work. Okay, it's important because when you make a mistake, and it's not if you make a mistake, but it's when you make a mistake, you want to be able to go back and check that. And the typical mistakes that people make have to do with, you know, when we're subtracting here, right? Making sure that those signs are correct. So one thing that a lot of people will do is they will just simply go through and change these. Okay, so negative times negative gives me positive. So I'm going to change that to positive and change that to positive. Negative times positive gives me negative. And then negative times negative gives me positive. And so I can change those signs ahead of time, and that will kind of help me keep track of that. Right. Vertical form, so again, I'm going to line these up vertically. So I've got -3x to the 4th, -3x cubed, positive 5x squared. And then I've got my linear term down here, that's squared, -4x. and then plus 4. Okay, so in standard form, right? So this would be a quartic polynomial with 5 terms, right? 5 terms, 1, 2, 3, 4, 5 terms. Leading coefficient is -1. Okay, and we're going to add these. So this is an x squared, so I'm going to put it by the x squared. Underneath the x squared, I've got -7x, and I've got +6. If I add these together, I get -3x to the 4th, -3x cubed. 5 plus 2 gives me 7 of the x squareds. -4 minus 7 gives me -11. Oops, -11x. And then 4 plus 6 gives me 10. Okay, so I end up with a quartic polynomial with 5 terms and a leading coefficient of -3. And then one last example here. So this one says vertical form. Again, it doesn't matter. Let's say that I decide instead I want to do this in horizontal form. All right, so I'm just going to do it in horizontal form. So first thing I'm going to do is I'm going to notice I'm subtracting here, right? So I'm going to go through and change these signs. This is going to become a negative, this is becoming a positive, and this is going to become a negative, and that's going to change that to a positive. Okay, so I've just distributed that -1, or I've gone through and subtracted, right? I've changed all those signs. So if I'm going to do this out in horizontal form, let's put the biggest degree first. And so it looks like 5th degree. So this is a quintic. This is also a 5th degree, so it's a quintic. So I'll write those out first, 12x to the 5th. And then this is negative or minus 7x to the 5th. And I like to cross these out as I do them as just sort of a bookkeeping thing so that I can keep track of which ones I've done. If I look for the next highest degree, that's going to be this this quartic here, right? So we got x to the 4th. Next, I'm going to have cubics. So I've got 1 cubic there for x cubed. I've got quadratics next, so about 2x squared. And then this is -4x squared. So I've got rid of all the quadratics. The next ones would be linear, but I don't appear to have any linears, and so I look for the constants, and so I'd have +3 here. Okay. And so now I just have to combine like terms. So there's some like terms there, those quintic terms. I've also got some quadratic terms here that are like terms, and the rest of these just have single terms there. So 12 minus 5 is 7. I'm sorry, 12 minus 7 is 5. 5x to the 5th. And then we've got 1x to the 4th. 4x cubed. And then we've got +2 minus 4. That's going to be -2x squared. No linear terms, and then we've got the 3 as the constant term. Okay, so we combine those together. It's written out in standard form. I can tell that this is a quintic polynomial with 1, 2, 3, 4, 5. So quintic polynomial with 5 terms. That leading coefficient is 5. Okay, so our goals today again are to can we use those names, right? Can we use those terms? Can we talk about a monomial, a binomial, a trinomial, a polynomial? Can we talk about the degree? Can we talk about constants and linears and quadratics and cubics and quartics and quintics and know what all those mean? Do we know what standard form is, right? Can we identify a polynomial by its degree and number of terms? Can we talk about the leading coefficient? And then can we do basic addition and subtraction of those? So the addition and subtraction, we're just simply, like I said, combining like terms. Okay, we're combining like terms and writing in standard form. All right. Okay, so take a look at the homework problems and let me know if you have any questions.